Things change over time. With every new day, our world gets enriched with new technologies. Familiar objects acquire new functions and unexpected add-ons. Heavy paper textbooks have been replaced by electronic reading devices such as e-readers, which can be used anywhere, anytime. The bulky, cumbersome life jackets have evolved over the time into the functional, comfortable and stylish life jackets. One such example of assertive refinement over the years was the creation of periodic table. The first version of periodic table was constructed by the Russian chemist Dmitry Ivanovich Mendeleev in 1869. 63 elements were known at that time, and they were arranged in horizontal rows in increasing order of their atomic masses. The table simplified and systematized the study of elements but had several anomalies. In 1913, Henry Moseley, an English physicist, found that atomic number was more significant for predicting the chemical behavior of elements than atomic mass, as had been previously thought by Mendeleev. So, Mendeleev's periodic law was modified and atomic number was adopted as the basis of the modern periodic table. In the modern periodic table, elements are arranged in the increasing order of their atomic number instead of atomic mass. This resolved some of the inconsistencies with Mendeleev's periodic table. For instance, argon has greater atomic mass than potassium, but lower atomic number. So, the placement of elements in increasing order of atomic number resolved the issue of placement of some elements with higher atomic mass before the one having lower atomic mass. The modern periodic law given by Henry Moseley stated that the properties of elements are the periodic function of their atomic number. The table based on modern periodic law is known as the modern periodic table, or the long form of the periodic table. As you read the periodic table from left to right, you will notice elements being arranged in the increasing order of their atomic numbers. The modern periodic table consists of 18 vertical columns called groups or families. These groups are numbered from 1 to 18. Two groups on the left of the modern periodic table are the alkali metals and the alkaline earth metals. On the far right are the noble gases or the inert gases. The 7 horizontal rows in the modern periodic table are called periods. The first period of the modern periodic table is called as very short period. It contains 2 elements, hydrogen and helium. The second and third periods of the modern periodic table are called as short periods. They contain 8 elements each. The fourth and fifth periods consists of 18 elements each and are called as long periods. The sixth and seventh periods consists of 32 elements each and are called very long periods. There are 2 series of 14 elements each having similar properties placed in 2 rows at the bottom of the periodic table to avoid it becoming too lengthy. These are known as the lanthanides and the actinides. Now, how do we decide the number of elements that can be present in a period? This can be explained by determining the maximum number of electrons that can be accommodated in the various shells of an atom. To calculate this, we use the formula 2n square, where n is the number of the given shell from the nucleus. For example, K shell can accommodate 2 electrons, hence the first period has 2 elements. L shell can accommodate 8 electrons, hence the second period has 8 elements. M shell can accommodate 18 electrons, but the outermost shell can only have 8 electrons. So, the third period also has 8 elements. The elements in a group have identical outer shell or valence shell electronic configuration. For example, if you look at the alkali metals present in group 1 of the periodic table, the electronic configuration of lithium is 2, 1. Sodium has electronic configuration of 2, 8, 1. And that of potassium is 2, 8, 8, 1. All these elements contain the same number of valence electrons. This is the reason why elements in a group show similar chemical properties. However, the number of shells increases as we go down the group. Now, let us consider the electronic configuration of elements in a period. Let us take the example of elements of second period. You can see that with the increasing atomic number, the number of valence electrons also increases by 1 unit, but the number of shells containing electrons remains the same. Thus, we can say that atoms of different elements with same number of shells occupied by electrons are placed in the same period. To summarize at the end, we can say that elements in the modern periodic table are arranged in the increasing order of their atomic numbers. The 18 vertical columns are called groups. The groups in the modern periodic table signify an identical outer shell configuration. Elements within the group have many similar properties because of the same number of valence electrons. The 7 horizontal rows in the modern periodic table are called as periods. Elements are placed in periods based on the number of shells in their atoms. Elements 57 to 71 and 89 to 103 fit into the periods 6 and 7. These are called as lanthanides and actinides respectively.